Hello, everyone. Welcome back. Today, I'm going to be doing part two of investigating the properties of linear relations. So, we're going to go through the homework questions that were given to you guys in order to make sure that we have a strong understanding. So, I do recommend trying this homework on your own before watching this session. Um, but if you're really stumped on the homework, it's also okay to watch this section as well. So, whatever you need to do. All right, so let's start with question one. Okay, so it says for a large building in downtown Toronto, many high windows must be washed. It can be very costly with the need of special equipment. The graph below displays the relationship between the cost and the number of windows being washed. Examine the graph and answer the questions below. The value of the y-intercept is what? Well, that would be 0, right? Because over here we have the point 0, 0. Because if we don't want any windows washed, it doesn't cost anything at all. We just wouldn't hire this company, to wash our windows, right? Or in other words, there's no fee just to get them to come out and wash windows, so to speak, right? So it's not as though we have to pay an initial one-time fee and then plus extra for every window we're washing. No, it's just it costs this much money per window with no upfront fee for them to come out and wash the windows. What does the y-intercept represent in this situation? Basically, it represents that like there is no initial cost or there's no initial fee that's needed to be paid before windows are washed. So I'll write that down. There is no initial fee charged before washing windows. Or another way we could put it as well is we could say that or we could also say that it costs $0 to wash 0 windows. Whereas this might not always be the case necessarily, right? Some companies might charge a fee just to come out and wash any number of windows, and then plus an initial fee per window they're actually washing. But this company doesn't do that. As long as you are getting at least one window washed, you are good. You are good to go. Does this graph represent direct or partial variation? This would be direct variation because the y-intercept is at 0, right? So there's no initial fee there to get your windows cleaned. It's just an amount per window, a rate per window. Find the slope and explain what the slope represents in the context. Well, let's see. We know that slope is equal to rise over run. So here's our rise, up 3, right? 3 over the run, which is 2. So therefore, it's 1.5. So basically, that represents the cost per window. So the slope represents the cost per window, right? So it costs $1.50 to wash one window, which, you know what? That seems like a pretty good deal. This must have been a deal from this question must be pretty old, because if it only costs, especially those big windows in downtown Toronto, if it only costs $1.50 per window, I would say that's a pretty good deal. I could imagine with that special equipment and everything, it costing at least $10 per window today. Paying a few hundred to $1,000 to get all the windows in a nice big building cleaned. But regardless, in this example, it costs $1.5, so $1.50 to have one window washed with this special equipment. The equation of the line is what? So here we have to use our answers from A and D. So from D we got $1.50, right? So slope is 1.5. Oops, I need to write y first. Y equals 1.5x plus b, which b was what? B was 0, right? So therefore the equation is just y equals 1.5x. We don't need to include plus b because it's just 0 anyways. Now let's use the equation to find out how much would it cost if 200 windows are washed. So y would be equal to 1.5 times 200, which is $300. So to wash 200 windows, it would only cost $300, which is a pretty great deal. Awesome. And if 480 windows were washed, it would cost how much? 1.5 times 480, which is 720. Awesome. Yeah, so $720 for 480 windows to be washed. Okay, use the equation to find out how many windows can be washed for $525 and $1,140. So let's see. 525 would equal 1.5 times x. So what we must do here is divide both sides by 1.5, and we get x is equal to 525 divided by 1.5. And when we plug that into our calculator, we will get 350. Okay, very good. Now let's do the same. 1,140 is equal to 1.5 times x. So if we divide both sides by 1.5, we get that x is equal to 1,140 divided by 1.5, which is equal to 760. So um, therefore, we can wash 350. Yes, we can wash 350 windows for $525, and we can wash 760 windows for $1,140. So there we have it. Okay, let's move on to question two. Looks like there's five, six. Oh, wow, there's lots of questions in this homework. That's all right. We'll go through all of them as best we can. This next one says Terry, a grade 9 student from St. Peter's, is a flyer delivery person for the Peterborough this week. They pay students a weekly amount plus money for each flyer they deliver. The graph below displays the relationship between earnings and the number of flyers delivered. Examine the graph and answer the following questions. The value of the y-intercept is what? Well, it looks like it's halfway between 50 and 60, so that would be 55. And what does it represent in the situation? Basically, it represents her base salary. It would represent her base salary, right? Before delivering any newspaper, right? So they pay a weekly amount, which is $55 just automatically, just for having the job. Plus, they pay extra depending how many flyers that she delivers. So even if she delivers no flyers, she still makes $55. Perhaps there's other tasks like meetings to go to or communications to do, or other reasons why she's earning that $55. Even without delivering anything, right? Because you'd think, well, don't you have to deliver flyers to make money? And yes, you have to. That's how part of her income gets made. But she also gets $55 just as her base salary for having this job, just for keeping this job. All right. Does this graph represent partial or direct variation? This would be partial variation. Partial variation. And why is that? Well, that's because our y-intercept is not at 0, right? There isn't that initial amount that she earns without actually having to deliver any flyers. So without delivering any flyers, she gets $55 rather than $0. whereas it would be direct variation if if delivering no flyers meant she'd make $0. Find the slope of a line and explain what the slope represents in the context. So m equals rise over run, as we know. Okay, so here we have 75 down to 55, so that's 20, right? That's our rise. Over run would be 500. So this is going to give us the number, basically the how much money she earns or per flyer. So I'd imagine it's probably not that much per flyer. Let's see, 20 divided by 500 is 0.04. So that means that she makes 4 cents for delivering one flyer, right? So after a whole neighborhood, she's made a few dollars, which is good. But one flyer barely gets her anything. Good. And what does that represent? It represents the amount of money for delivering one flyer, which is 4 cents. Which is 4 cents. So not a lot. The equation of the line y equals mx plus b is what? Well, let's see. It's 4 cents per flyer plus the initial $55 that she gets because she works at this job. Oh, and I forgot my x. I just put 0.04. It should be x plus 55, like that. Use the equation to find earnings if 2,250 flyers are delivered. Well, let's see. Y equals 0.04, so 4 cents per flyer. 2,250 flyers are delivered, plus the initial $55 that she makes that week just for having the job and perhaps doing other tasks associated with having the job. So that's going to be 90 plus 55, which is $145 in total. Awesome. All right, what if 80,000 flyers are delivered? Which, by the way, 80,000, that's a lot more than 2,250, so she's probably going to make a lot more money, even though it's only 4 cents per flyer. That's a lot of flyers. That would take a very long time. That's going to be a lot of neighborhoods for sure. So that's $3,200 plus the $55. Okay, well, you know what? At least she makes good money. I mean, that's at least if you do that much work in a week, you make pretty good money. I mean, a lot of people wouldn't make that in a month, so that's something. So for delivering 80,000 flyers, she will make $3,255. So that's quite a nice chunk of change there. All right. Use the equation to find the number of flyers delivered if the earnings are $155 and $635. So let's do that next. All right, so let's continue on. Use the equation to find the number of flyers delivered if the earnings are $155 or $635. Okay, so if they're $155, that means Y would be 155, right? Because Y represents the number of dollars earned. And then we need to find X. So what's the first thing we must do? We must subtract 55 from both sides. So on the left, we'll have 100. And on the right, we'll just have 0.04x because we're subtracting 55 from both sides. Then we're going to do 100 divide by 0.04 to get the answer. So that's going to be 2,500. So therefore, we need to deliver 2,500 flyers if we want to earn $155 that week. Let's say we want to earn $635 that week. Well, that's going to be $635 is going to have to equal 0.04x plus 55. So we must subtract 55 from both sides, meaning we'll get 580 over here and 0.04x here. Then we must divide both sides by 0.04. So then x would be equal to 14,500. So therefore, we must deliver 14,500 flyers if we want to make $635. Good. Okay, let's try another one. And I mean, I'm sure you've caught on by now. These are all very similar. It's good to practice this a bunch, but these are all very, very similar questions. The cost of a taxi ride in Peterborough depends on the distance the taxi is driven. The recorded data distance kilometers and the cost of the taxi ride is represented in the graph below. Examine the graph and answer the questions. The value of the y-intercept is, well, it looks like it's 3, right? Because it's partway between 2 and 4, so I'm going to say 3. What does the y-intercept represent in this situation? I would say it represents, let's see, it represents the cost without any distance being traveled, right? So when we haven't traveled at all, it's $3. So looks like there's like a one-time $3 surcharge to ride a taxi at all. And then we just continue to ride it, right? So what does the y-intercept represent in the situation? It represents the initial cost of taking a taxi. Good. Okay. C says, does this graph represent direct or partial variation? It represents partial variation. Now, why? Why does it represent partial variation? Well, that's because the y-intercept is not 0. So there is that initial surcharge before we can even take the taxi anywhere. We must pay $3 just to do anything with the taxi. Find the slope of the line and explain what the slope represents in the context. So in terms of what it's going to represent, we already know that. It's going to be telling us the number of kilometers, or sorry, the number of dollars per kilometer. So it represents, let's write that first, it represents, oh, come on. Okay, so it represents the dollars per kilometer, or I should just say cost per kilometer. There we go. Okay. So what is the slope? Well, let's see. The slope is rise over run, right? So what's the rise? The rise is, looks like $5 over run, which is $3. So therefore, it costs 5 over $3, which is what? That costs about $1.67 per kilometer, right? So it costs, and originally it cost $3, but the slope's representing that every kilometer that this taxi driver drives, we must pay the taxi driver $1.67 for their labor and their costs as well of doing the driving. Okay, so y equals to mx plus b. So y is equal to 1.67x plus 3, like that. Good. All right, so then it says use the equation to find the cost of the taxi that is 20 kilometers or 50 kilometers. So let's do that. Use the equation to find the cost of a taxi ride that's 20 kilometers. So y would be equal to 1.67 times 20 kilometers plus 3, which, let's see, that is going to be 1.67 times 20 plus 3, which is going to be 33.40 plus 3, which is 36.40. So therefore, it would cost $36.40 to drive, to take a taxi for 20 kilometers. Now, how about for 50 kilometers? Y is equal to 1.67 times 50 kilometers plus 3, which is equal to, let's see, 1.67 times 50 is $83.5 plus 3, which is going to be $86.50. So therefore, it would cost $86.50 to ride a taxi for 50 kilometers, which, I mean, that's a lot of money, but that's also a pretty far taxi ride. That taxi ride could easily end up taking, I mean, at least half an hour, likely more. So also pretty long taxi ride for sure too. All right, use the equation to find out how far the cab ride would be if the cost is $73 or $40. So let's do $73 first. So if it's $73, we need to find out what x is, right? How far did the cab travel? So our first step is we're going to subtract 3 from both sides. So over here we're going to have 70 equals 1.67x. Then we're going to divide by 1.67 on both sides. Which is going to be 41.9. So therefore, the taxi was able to go about 41.9 kilometers if we paid $73. And then if we paid $40, then we first take away 3 from both sides, and then we divide both sides by 1.67. So 37 divided by 1.67 is about 22.2 kilometers. So close to 22.2 kilometers if the cab ride costs about $40. So there we have it. All right, so there's still question 4, 5, 6, up to 8, 9. Oh, wow. All right, I gave a lot of homework, turns out. I will do the rest of these questions. That'll be in the next lesson. So in the next lesson, part 3 of this, we'll do at least question 4, 5, and 6. We'll do a few more questions, and I will see everyone for that. Bye, everyone.